In this video, we'll explain in further detail about the different Z-planes that you can use within the PartMaster 2D and 2.5D CAD-CAM system. Okay, so I'm in the CAD software now, and these are a couple of drawings which are supplied as part of the standard drawings. So they're called Z-planes and Z-planes 2. So you should have these on your system. If you don't have them, then just let us know and we'll email them to you. Okay, so there's 3 or 4 things that you need to just be aware of when you're setting the Z-plane. So if we look at this drawing first, these are the planes and what they actually refer to. So the first thing at the top is the tool change and safety position. So this is where the machine tool will go to when it changes tools and where its safe position is. So this is above everything. So this should be the maximum in Z that your machine is capable of. Now, on some controllers, on most modern controllers, of course, you don't need to drive the tool to a particular XYZ tool change position, because the tool will retract and then the automatic tool changer will kick in and it will change the tool at whatever position it is. But in any event, if you do need to set up the safety position, then I'll show you how we do that in the CAM software. The clearance plane is a position where the software will rapid to and retract to, and this should be clear of any fixturing or any clamps or anything else, because this is the plane at where the rapid motions will take place in XY. So for instance, if the tool happens to be cutting something here and we then want it to cut something over here, it will retract up to the clearance plane, rapid across to the next XY position, and then proceed to cut the next part. So the clearance plane is something which is clear of all obstructions. The feed change plane is a distance and it's measured above the work surface. The work surface is a movable value which applies to, in its first instance, to the very top of the job. So normally the top of the job, the work surface is set to Z0, and the feed change plane is a distance measured from the current work surface. So when you create the contours, you'll have a work surface, you'll have a depth, and you'll have the feed change plane associated with that. So these are any fixtures and this is the machine table. So the recommended method is to have the top of the job as Z0. What that means then is that if in the G-code file you see any Z positive values, you know the tool is above the top of the job. Any negative Z values mean the tool is below the job and could be in the material. So if we move on to this drawing over here, so as you can see, there are various features within this drawing, and we can create the contours and use the values that we set to produce a part which looks similar to what you see here in the CAM software. So the first thing that we'll do is we'll set the contours. So if we go into the NC mode, then we'll select the contour. So let's start off with this contour here at the top. So this refers to this top contour here, and it's going to cut down to there. So this is the contour, and we'll call this COM1. Its Z surface or work surface is 0, and the depth, if we look at the drawing, the depth is measured from there, and that is 20 millimeters. It doesn't need to be minus because it's a depth, therefore it goes into the material. Okay, so that creates that contour there. Now we'll do the next one, which is this one here, and this one has the same Z surface or work surface, which is 0, as we can see from the side view here, but this time the depth is 10. And that creates that contour. Now we can move on to the outside shape. So in this instance, we'll create the contour, but its work surface will be measured from Z0, and it's a minus value because it's going down. So a work surface can be plus or it can be minus. A depth is always a positive value because it's measured from the current work surface. So the work surface or Z surface here is minus 20, and the depth of that is measured from that work surface down. So the depth is 30. And that creates that outside contour. Now we'll create the holes, and we'll use the pattern command. So we go to the first one here, and again, because that is below the Z0, the work surface 0, the pattern which we're going to create has a work surface of minus 20, and the depth is the same, 30, because those holes go right the way through. So that's the second point in the pattern, that's the third point, and now I hold down the shift key to indicate that this is the last point in the pattern. So that has been created. Okay, so now if we save that away, I'll just call it temp, and we'll take that through into machining. Okay, so those are the contours that's created. When we come into a new job, we need to set the machine setup, and the thing that we need to check on is the tool change position. So the tool change and safety position can be the same or they can be separate. Again, this depends very much on the type of machine that you're working on. On older type machines, you may have to drive the table to a particular XY location before the tool changer is allowed to kick in. But on most modern machines, it doesn't matter. The clearance plane specifies the Z height, which is clear of all obstructions. Okay, this case it's 50 millimeters, 2 inches. And the feed change plane is set to 3. So this is a default, but it can be changed, and you'll see that in a moment. And again, these options down here, mostly these are required for older type machines, but in most cases you don't need those. But if you do, they're fairly self-explanatory as to what they do. Okay, so if we now look at this in the isometric view and the front view, we can see that the contours have been created with the depths specified within the contours. So if we wanted to do any machining on that, let's choose a small tool. Let's do the drills first, just for the sake of it. Let's have a drill, 10 mil. Select that tool for use, and we'll do a drill pattern. And let's have a peck drill. Now you'll notice that when you choose a pattern or a contour, it has the feed change plane, which was the default 3 millimeters. It has the work surface, and the depth of the holes are taken from the pattern as we described it in the CAD system. But if you want to change that, you can just simply change the values here. It won't go backwards and change the drawing, but it will change it will override the parameters that we set within the drawing. So if this is a peck drill, we set the number of pecks. Okay, now what happens here, because the work surface is below 0 and the feed change plane is associated with that, what will happen is that, let's just switch it into centerline view. So the tool starts off at its tool change position, rapids across to the first XY location, rapids down to the feed change plane, which is above the pattern in this case. So if we look in the front view and run that, So tool change position here, rapids down to the clearance plane in X, Y and Z, then rapids down to the feed change plane, which is 3 millimeters above the current work surface. So the work surface for that pattern is at -20. So what that means is that instead of rapiding down to a distance above the top of the job and then feeding all the way down, and in this case we don't want that to happen obviously because there's no material there, so we can use the feed change plane associated with the pattern or contour, and it rapids to that position and then goes into feed rate and produces the cycle that you want. If you want to look at the front view and choose tool envelope, then you can see the tool tip moving down, and these are the peck distances. Notice also that when you do drilling, part of the drilling dialog box is to add on the tool lead to the drill hole depth such that the hole is drilled completely to the diameter. If you don't want that to happen, there's a switch in the drill dialog box says ignore the tool's lead value. And if you want to know what that is, we go back into here, and this is the lead. So this calculates the lead based on a 118-degree drill tip, but you can set that to whatever you like. Okay, so that's done, just an example of that. Just following on from there, if we did want to do some more milling, let's choose a 20mm cutter. Select that tool for use, set the speeds and feeds. Okay, so that's the tool diameter that we're going to cut, and we'll go into the plan view and we're going to area clear this shape here. So there's two methods of doing that. We could use the outside boundary and the inside boundary as an island, and to do that we would use the area clear command. So that's the outside shape, and an island is this one. And the thing to bear in mind here is that it will take the values from the contour, which is the outside shape. Now in that case, that's not what we want, because the contour starts at -20 for the outside shape, but we want to machine that material away. So we can simply set that to 0 and 20 just for this particular machining operation. And if we wanted to, we can set the we can leave a finishing allowance on there if we want to, or we can leave it as 0. So let's just see what that does. Okay, so if we run that, and if we go back into that area clear, if we want to set Z steps, then we can do, make that 2mm, and so on. So hopefully that gives you a better understanding of the various terms that we use to set the Z values and how they apply to a job.